and then to the viewers of Sailing Yaguara, to welcome you all to Station 10 Simonstown. Nicholas has very kindly decided to do a bit of a feature on us, so we hope that you're all going to enjoy your tour with us. We're going to give you a walk through our station and show you our new rescue boat and give you some idea of how we do our business. You want to follow me, Nicholas?
Thank you.
Morning, everybody. Welcome to NSRI Simonstown. My name is Darren, I'm the station commander. My colleague here, Simon, is my deputy station commander. Come through. So the area we're in now is what we call our operational area. We're going to first move upstairs where we have our training facility, we have our control center, and we have a little bit of relaxation area and galley areas for the crew. So if you want to follow me through. So the NSRI Simonstown building that we're going to show you today is relatively new. The building was completed in end of 2020. It was a purpose-designed building to accommodate the new rescue boat, the Donna Nicholas. The previous building was too small to house it. The previous building was also built in the early 80s. It was cladded with old asbestos sheeting, and for many reasons the building was due for an upgrade. We completely demolished that building and we built this fantastic base, which you're going to see more of now as we go. So I'll start off by showing you our training room, which is where we do all our theoretical training largely. So everything from basic seamanship to navigation, collision regulations, first aid training, firefighting, survival at sea, everything pertaining to sea rescue. Even engineering lessons about the vessels. All our crew need to have a very good engineering understanding. All of that takes place in here, and we can seat up to 20 people at a time. So as we come through to what we call the crew area, and this is really where the guys just do a little bit of relaxation. Not that we have a lot of time to relax when we're here, but certainly where the guys would enjoy a cup of coffee and a chat, maybe have a sandwich or whatever. This is the area where that would take place. We also will use this area to do any of our debriefing after we've done a rescue or an exercise, or a pre-briefing should we be going out to do a rescue or an exercise. We would do that in this area here. Coming through this side is our kitchen area. Nautical terminology, we call it the galley, as one would, and we're able to prepare a meal for the rescue crew when they're coming back from a deep sea rescue where they've been out for maybe 12 to 18 hours. Then the facility has got stove, gas stove and oven and things where you can actually cook a meal for the crews and be ready when they get back after being at sea for long hours. And that is kind of why our galley area is very similar to that of someone's home, where the station isn't manned all the time, but we need to still be able to facilitate the normal making a meal for the crews. We're going to go through now to the control room. So when the sea rescue boats launch and go to sea, We have a control room which is manned by one, sometimes two controllers, and both for training or for an operation, for an actual rescue. This gets manned where they are doing, where they are plotting the vessel's position on an ongoing basis every 15 to 20 minutes. They are facilitating communications through VHF as well as digital trunking. We have areas where we lose the line of sight on the VHFs, in which case we'll use the digital trunking, known to most people around here as the Cabicom radio, and that is linking through various repeaters and networks around the coast. So even if the boat is 150 miles up the coast, we can still do direct call to the vessel, whereas with VHF, obviously you can't. The control room is set up in a manner where we sometimes run what we call a multi-asset rescue, where it's a large rescue where we might have 5 or 6 rescue vessels involved in that rescue, and we're covering a large search area, and we may need to move the different search areas onto different channels, different operating channels by VHF, and that is why we have 2 VHFs that are stationed far away from each other. So you have one controller managing the rescue in one sector and another controller managing the rescue in a different sector with on a different operating channel. So we'll split the communication out to make it much simpler, otherwise everyone's talking over each other. Up here, the screens are not on at the moment, but we also monitor Safe Tracks. Safe Tracks is an app that Sea Rescue uses whereby people are able to log their vessel details, and they can log their passage plan onto that app, and the app will monitor the progress of their passage. So if they're overdue for their destination and their ETA, it will alert us, or the vessel can also push a panic button on the app. And that information all comes through up on a screen, and we're able to then locate them, track them, communicate with them. If they can't communicate, we at least know their position, or we at least know their last known position. We also run the app on board the rescue boat on an iPad, on a tablet. So once we're aboard the boat and we're heading out to sea, we can then continue to track the Safe Tracks operator or the Safe Tracks user on board the rescue vessel by using Navionics and by using the app on a tablet. Alright, and then another feature that we have in Simonstown is what we call our Coast Watchers program. We have about 12 people who are scattered around the high-lying mountainous areas along our area of operation, starting from Muizenberg, going all the way around as far as Partridge Point. And those Coast Watchers are activated with every rescue that we activate on. They are alerted to those rescue calls so that they're able to then get their eyes on the water and start feeding information back to us. So if they're seeing a vessel or seeing a target that we may be looking for, they are taking bearings on those targets and they're feeding back the information for us in terms of the bearings and the distance. And where we're getting multiple bearings from multiple Coast Watchers, we're able to cross-reference those to giving us a search area for whatever we're looking for. Up here on the board is all our Coast Watchers' names, and interestingly enough, if you want to come a little bit closer, Nicholas, you'll see all these multicolored lines, and that is telling us where Coast Watcher 9 is, and the orange line up and the orange line down shows us what area of view Coast Watcher number 9 has. And then we're able to phone Coast Watcher number 9 if need be and say, we're looking for something in your area of view, please will you have a look out, and then feeding information back. Very successful program. We've saved many lives where the weather conditions are so bad or so severe that the rescue boat can't see what they're looking for, even though they're within a few hundred meters of the target. But the Coast Watchers have been able to guide us in to that exact target. And we have literally pulled people up out of the water that we probably would not have found if it wasn't for the Coast Watchers. is what we call the operational area of the station. You'll see by the way the doors have been set up that only the rescue crew, the boat's crews and the winch operators are the only personnel that are allowed into this area. This area houses our rescue vehicle, it houses our diesel bowser for refueling the rescue boat, it houses the deep sea or the offshore rescue boat, and it houses our surf rescue vessel as well. Okay, so both these vessels are launched on a hydraulic winch system. The hydraulic winches on the station are both supported by one hydraulic pack with changeover valves between the two winches as need be. We also, if you want to pan this way a little bit, Nicholas, you'll see that there's also a diesel generator which has been attached to this. When we have either load shedding or power failure in an emergency, we're still able to operate our winches. A little bit slower, but we do have a diesel backup to that. So we have the main pack over there. We then have the main hydraulic winch over here for this big boat. And then as we come around, here, you'll then see very strategically placed the hydraulic control box, and the reason it's placed here is so that from a safety perspective, whoever's operating and moving this very heavy equipment is able to see behind these assets at all times to make sure that there aren't any kids or any debris on the slipway, anything that poses somewhat of a hazard. So that's why it's strategically placed. There's a whole range of lights on here, and very simply there are sensors on the doors which allows the winch to operate or not operate. If the door is not fully up into the open position, you won't get a green light and the brake will not release on the hydraulic system. So that's a safety that's been put in place so that we don't accidentally put the boats through the doors. Okay, so as part of the way that the ergonomics of the station was set out, on our way to the rescue boats, we will collect our wetsuits, and then from there we go into the change rooms to get changed, and then from there we can then board the rescue boat. So it's all in the flow. So here you're going to have the men's change rooms and the ladies' change rooms of equal size. On this station, we're quite close to having 50% ladies, 50% men. And I think it's important that that gets said. There's often some understanding that this is very much of a men's environment, where it definitely isn't. We've got quite a lot now lady skippers who skipper and take command of the rescue boats. Many years ago when I first joined, the station had one ablution facility which only had that man standing on it. Whereas today the organization has really evolved, and we now have all sorts of people from all different walks of life, and a very strong mix between both male and female. And we have lots of females that are outshining some of the men by a long way. So it's definitely something that this station has always been very proud of, is that you know, the transformation is happening and has happened. So Nicholas, if you just walk with me a little bit, I think what you immediately get a sense of when you look in our change rooms is that our rescue stations are very much a semi-industrial environment. These facilities are funded by public funding, and it's very important that from a public funding perspective that we are not building palaces, we are building very usable semi-commercial environments that is very suited to what is actually needed, and that we don't go beyond that. That's public money we're using, so we've got to build what we need. And this is a typical bathroom environment or a change room environment in a rescue station. We don't have showers for every single crew member. You know, we will put in what we need, and we'll put in based on the environment and what type of work we do. If we were a surf rescue station, where they're working in a very wet environment. You might have 6 showers, whereas in this station, we'll go to sea on a rescue boat where we have 1 or 2 rescue swimmers, but the rest are not rescue swimmers. We don't need to do more than that. So the stations are very much designed around the type of business it does, if that makes sense. Okay, so this is a 6.5 meter Gemini. It's a surf rescue boat. It's designed specifically to work in the surf environment. She's a self-righting boat, which means she's got a righting equipment on board. So should the boat roll over, the crew have a procedure to follow where they eventually will pull the righting equipment, the bag will inflate, and it will right the boat back up. The boat is designed to operate with a coxswain and 2 to maybe 3 crew, so a total of 4. She's designed to work comfortably with that. And she is an all-weather craft. She'll operate in any weather conditions that we have. We use her mostly for the inshore rescue. Although she is licensed to operate up to 40 nautical miles offshore, we do that very much weather dependently, depending what the call is and where we're going. We prefer in the heavy weather conditions to keep her inshore, just because she doesn't have the same protection for the crew as the other boats do. She currently is now about 8 years old, and she was sponsored by the surf ski community, and she does a fair amount of surf ski work in the area, and they have sponsored a few of these now around the coastline. So every station around the country has a rescue vehicle. The rescue vehicle is used for multiple purposes. Everything from radio relaying, so it will move down the coast where it will act as a radio relay between the rescue vessel and the base. It's used for transporting crew, moving them around, collecting fuel, towing the bowser, and also used as a medical response vehicle for beach drownings. Sometimes even if there's been a motor vehicle accident up the road, it might be an initial response to that. So she's fully kitted out with a full set of medical equipment and extrication equipment, and obviously with the various communication devices such as VHF radio, etc. Okay, welcome everybody. We're now on board the Donna Nicholas. She is the second boat to be built of the new offshore rescue class vessel for NSRI, the 14 meter. This vessel was built as a hull deck and bulkheads in Lorient in France. She was shipped to South Africa in a shell, where she was then used as a plug to build the rest of the molds, which would then build the rest of the fleet for the country. The boat was then fitted out and completed by Two Oceans Marine, and then arrived on station in April 2021, and after a few months of a workup, she is now fully operational in Simonstown. Okay, we're going to start off, Nicholas, by stepping into the cabin. what is an important feature of this boat is that this entire cabin is suspended on this boat on rubber mountings, and that helps a lot with the shock that's coming up through the hull when we're running into heavy weather, and also it helps with the electronics and any electronic or electrical interferences that may resonate through into the boat, be it from other electrical components or from the engines. So this whole cabin is actually built separate to the boat and is mounted onto these rubber cushions. If you come into the cabin, the boat is specifically designed to operate with a crew of 6. So there are 6 seats on board. So we believe that all the crew should have their own seat where they are safely strapped into. The vessel is designed to operate with 6 crew, as I said. There are therefore 6 seats. Each seat has got a strap on it that the crew can be strapped in properly. The seats are also all cushioned with air cushions that you can adjust. So depending on the weight of the crew member, they can then find what is comfortable for them. When you're running into a big sea and you are seated, it is important that you're not sending that shock up through the spine of the crew member. And everyone is strapped in. The boat is designed as a rollover, self-righting vessel. And if the boat was to roll over, it's very important that the crew members are strapped in to their seats in order not to hurt themselves. The boat is equipped with some state-of-the-art equipment. We're running all touchscreen Furuno on board, and the navigator, who normally sits over here, is responsible for setting up all the passages and the waypoints of where we're going, and all that information is then automatically fed through to the other screens. I think what is important, in addition to the basic information that is being fed through our electronic equipment, is some more interesting and more useful aspects of it. Would be that firstly, on the radar it has an ARPA function, so we're able to pick up multiple vessels at sea and track those vessels, and we can track the direction and the speed that those vessels are doing, and it makes our navigation and passage much safer, especially when we are towing vessels where we've got long tow lines behind us, we're moving very slowly and we're coming across shipping lanes, that we're able to predetermine if we have any potential collision courses. And this equipment is absolutely fantastic for that. Also, we are able to pick up and transmit AIS information. AIS obviously is the vessel's information, as well as the vessel's course and speed and intentions, and that of other vessels as well. So all AIS targets. We also have on every single one of these life jackets, we have a Plb device, which is a personal locating beacon. Should a crew member fall overboard, they can activate that unit, and those also come up on our display screens, so we're immediately able to hopefully recover our overboard crew member. Another great feature is having the FLIR, which is a forward-looking infrared, which can be controlled both at the navigator's position but also here at the coxswain's position. And using a FLIR camera, we're able to do thermal imaging where we are looking for someone, or even a vessel for that matter, at sea, where it's giving us the thermal trace on that person or that boat, as well as a night vision option within that, where we can actually look at a vessel that might not have any lights on. We can use that type of stuff, and especially if we're looking for a surf ski or someone at night, we're able to use that feature, which works well. So as I said earlier, the boat is designed to work with 6 crew. That 6 crew is made up of a helmsman, the coxswain of the boat, who sits in this chair over here, and he manages everything that's happening on the boat. Then there is a navigator who sits at the back. Next to the navigator will be the bosun, who also is the engineer on board. And then we have 2 rescue swimmers, or 2 deck crew who double as rescue swimmers, who will sit in the other seat. So as I was saying earlier, the navigation being set up by the nav desk, that information is being displayed on these screens. The coxswain is responsible for making sure that he is happy with the safe passage of the vessel. He also monitors the communication, which is managed by the navigator, but the coxswain's able to listen and intervene or communicate. And in every aspect of the running of the boat, it's like a captain who runs his ship. He has people working in the different departments, but he oversees to make sure that he's happy with how all that's unfolding. we've now come down into what we call the forward accommodation space, where I'm standing. Closer to where you are at the moment, that is where we keep our anchor and fenders and all that. And then just this side of it is wet lockers for hanging up the rescue swimmer equipment and maybe our mustos and stuff like that. That's all in the wet area. In this area serves two purposes. The one is what we call our survivor area. The boat is designed to take 18 to 19 survivors off a vessel, and we cram them into this area. We've got seating there, we've got seating that side, and we've got more seating around the corner here. It also holds all our medical and rescue equipment on the one corner with oxygen and suction units and defibrillators and that. We've got all that on board. Over here we've got a basket, and the vessel has a small manual crane. We can connect the basket to the crane, lower it into the water, and lift a casualty out the water, swing them back on deck. So we have that. And then our biggest feature is that we have a galley, which we've never had before. So the vessel's got a small galley area where we can make a cup of coffee. It's got a microwave, so we can heat up a small meal or whatever. And we have fresh water on board, which is pumped up through a little urn for making coffee, which has been nicely set up, and it's a great feature for the crew, especially when we're doing those long 18 to 24, 25 hour rescues. We're going to be coming into the engine room now, so if you want to just watch your step please as you come through. And we're going to talk a little bit about what we find in this compartment. So this boat is powered by two 600 horsepower Cummins motors. The boat has been set up in what we call a V-drive configuration. So these engines are actually sitting back to front. The gearboxes are on the forward side, and the shafts are actually going in underneath the engine, so they've been turned around. Some nice features about this boat is that it has firefighting capabilities. So there are jabscope pumps that have been set off these engines that are on power takeoffs, supplying water to two outlets on the deck to fire hoses. So we're able to get close to a vessel that's on fire, and we can hopefully help to reduce the fire or put the fire out. In addition to that, these jabscope pumps also double up as emergency bilge suctioning. So all 5 compartments in the boat has the ability to have the bilges pumped from the mechanics of the engine, in addition to the normal electric pumps that are laid out through the boat with all the high water alarms and float levels. If you can look at the door right next to you, you'll see on the door there's a color-coded chart, and the color-coded chart will show you the color coding of all the different pipes. You'll see yellow, blue, green, all taped on all the piping around here, and that indicates to us whether it's a bilge pipe, whether it's a fuel line, whether it's a freshwater line, and it also has arrows which tells us which way all the directions flow. And in this environment where we are volunteers, and some of us aren't marine engineers, that type of thing is very helpful when it comes to tracing what pipe goes where and which valve we're going to need to open when. The boat has got 2,000 litres of diesel, so it's got 1,000 litres per tank. She has a range of, at 18 knots, we can do 400 odd miles with the boat. One of the features of this boat is that we want the boat to last 40 years. She was built and designed to last 40 years. And for that reason, these engines get flushed with fresh water every time we come back from sea. We have a sequence where we close off the intake seawater system. We connect 1,000 litres set up in a dump tank upstairs, which is connected to the boat. We open these green valves, which then closes the seawater and allows fresh water to come in, and each engine gets run for 2 minutes. And then once we shut down, we obviously close all that, we reopen the seawater, and we disconnect the fresh water. That means that when she's standing during the week, or for a couple of weeks at a time, she's standing with fresh water in her water jackets as opposed to seawater. In addition to that, we have double banks of fuel filters. If you're able to look, you'll see the fuel filters here. We're running 2 filters. One is always in service at a time, and if the filter starts to block up, the vacuum gauge will tell us that it's starting to draw heavy vacuum, in which case we'll flip the valve and we'll go to the fresh filter, and while we're running a fresh filter, we'll change out the filter on that. We built these boxes that we can do this kind of thing at sea without spilling diesel into the bilges. This is the final compartment. This is what we call our tiller flat. This is where the rudders are positioned in the boat, and the rudders are joined with what we call a tie bar, and then there's a hydraulic power pack driving the hydraulic ram, which is then obviously pushing the rudders back and forth. In the event that we lose our hydraulics, we have what this is called the emergency steering. We have a through hole fitting there where we can attach the emergency steering onto one of the rudders, and then we can steer the boat through that. Also in this compartment is all the batteries for the boat is here. We have our starting bank sitting on the port side, and we have our 24-volt house bank sitting on the starboard side, and then all the engine batteries are also in this compartment. In the event that there's a fire and we need to isolate this on our way out, coming through the compartment, you can isolate the battery banks, both over there, and then the house battery bank right next to the other side, and then you can escape out through this hatch over here. So if there's a fire in the engine room and you're stuck in here, you can go out through this aft hatch, which is a legal requirement that you're able to escape. There's an escape hatch sitting here, and then there's another escape hatch in the forward accommodation space as well, where you can get out should there be a fire in the cabin area and we can't get up past that. We're running 3 systems on board. We have a 24-volt system which powers the startup of these and some of our house equipment. We then have a 220 system which is supplied either by shore supply, or when we're in the water and running, we will then run inverters which is supplying the 220 system. We have additional alternators on these engines over and above the normal manufacturer alternators, which helps to replace that battery capacity when we're running inverters. And the inverters serve the purpose largely of running the air conditioning in the boat when we're at sea. Air conditioning downstairs, air conditioning upstairs. As I said earlier, the boat is a rollover boat, so when we're at sea in heavy weather, we keep the doors all closed, which means we then need air conditioning inside the boat. We then also running 12-volt systems, which is running our GMDSS, which is our communication system, our VHF radios, and that is all 12-volt system. So those are the 3 electrical systems that we're running on board. That's the 24-volt DC panel that drives all the 24-volt equipment in the boat. As we're moving aft through the boat, we have another 3 compartments that we're going to be accessing. This compartment is what we call our tank fuel space. It also has a workbench for us to do basic mechanics. Underneath, all our spares and tools are stored down there. And then on this side, we have a heads, which for the landlubbers is a toilet, which is also part of that tank space over there. We're just waiting on these things to boot up, Nicholas. They're like little computers, so they're gonna be able to register before we can run. Okay, I'm going to start up starboard engine first. Confirm I can start starboard. Can we check for water overboard, please? Check for water overboard. Okay, water overboard. I'm starting port. Check for water overboard, please. Okay, we've got water overboard both sides, and I've got oil pressure.
And then engine hours, please.
Engine hours 210. So it's starboard.
Thank you very much.
must not be released before you stir. Okay, even if they're only 3 seconds apart, don't let the one go before the other.
So the NSRI is the only sea rescue operation in South Africa. It operates with over 1,000 volunteers, 42 stations around the country, 5 satellite stations. Some of the stations would be deep water stations like this one with the larger craft. We also have the surf stations like at Strandfontein, where operations are mainly in the surf. The operation is funded by public funds. It's an NGO, of course, public funded NGO, and donations will come in either to head office or to a station directly. But the best way to go about that is to just log on to the NSRI webpage, and there's a click here to donate type button, and you can specify which station you would like funds to go for any specific project that we're working on. We might ask the local community for assistance there, but generally everything's through head office, and funds are disseminated as and when required. The webpage for the NSRI would be nsri.org.za.
Station 10 Simonstown is manned by just over 50 volunteers. The volunteer crews make up both the sea game crew as well as our shore crew, which is operating the rescue vehicle, winches, launching the boats, and then our control room operators. And then in addition to that, we have about 12 coast watchers who are members of the station and scattered along the coastline at their residence, and they are assisting by getting eyes on the water and telling us what they're seeing and which way we need to go or where the incident might be taking place. So that makes up the entirety of the volunteers on station. As Simon said earlier, we're running 3 watches, so the guys are on duty 24/7 for their 7-day rotation, and most of the training is done on weekends, remembering that all our volunteers, or most of our volunteers, are working, or students, or some are retired, but most of them are working, and their off time is really evenings and weekends.
So thanks for coming on the tour of the base with us. We hope you've enjoyed it. Thanks to all of those of you that have made donations to the station in the past and to the organisation. And for those of you that may be considering or looking for something to donate to, I think you'll find this is a worthy cause. Darren, over to you for a last word.
Yeah, I think same as what Simon said, thank you very much, I think, to our community and anybody else there who continually supports us. I think without the support we wouldn't be able to float our boats, so we are very grateful and thank you very much. Yeah, I think just wishing everybody all the best for the new year ahead, and please just remember when you're out there, don't forget to use safe tracks, and safety, look after yourselves on the water, and yeah, thank you very much.